Welcome to AirTag versus AirFinder. We're going to give people a few minutes to get joined in. We've got people coming in right now, so we'll get started in just a few minutes. Thanks for joining. If you're just joining us, we're giving people a few minutes to get into the webinar and then we'll get started. Welcome everyone. We've got people continuing to join, so we're just going to give them a minute and then we'll get started. Well, thank you so much for joining us for AirTag versus AirFinder, selecting the best tracker for enterprises. My name is Jennifer Halstead. I'm the CFO here at Link Labs, and I'm pleased to introduce Bob Proctor and Mark Bloechl, who will be presenting today. Dr. Bob Proctor is the CEO of Link Labs, and he holds a PhD in applied physics from Cornell University. He has decades of senior executive experience in public companies, including line, staff, and IPO leadership positions. He served as global head of marketing at Corporate Executive Board and associate principal at McKinsey & Company. Bob, it's great to have you today.
Thank you, Jennifer.
We also have Mark Bloechl, who's our chief engineer. He is responsible for developing our cutting-edge location technologies. He specializes in embedded firmware, signal processing, and low-power hardware design. Before Link Labs, Mark spent 8 years at the Johns Hopkins Applied Physics Lab, designing custom RF devices for the US government. Mark has a master's in electrical engineering from Johns Hopkins University. Mark, it's great to have you today as well.
Thanks.
All right, Bob, I'll pass it to you.
Thank you, Jennifer. And welcome everyone to our webinar today on AirTags, Apple's AirTags versus AirFinder, which is a Link Labs asset tracking and monitoring platform, and trying to understand sort of what's best for enterprises. I'm going to do sort of 3 or 4 sections today as sort of what Mark and I will lead you through in a very conversational way. I want to spend 3 or 4 slides just talking about Link Labs and our experience, and part of this is to give you a sense of where we're coming from. Hopefully we'll be able to convey that we've been in this space for a very long time and know it in tremendous detail. But also I think you'll be able to get a sense of where our knowledge sort of starts and stops with that kind of introduction. We'll shift and Mark will start leading the conversation as we introduce the AirTag product, the AirFinder product, and Mark will lead us kind of getting under the hood of each of those to start to really compare them. And then we'll sort of pull up and have a dialogue around use cases and how these might be applied in real world situations. As we go, feel free to send questions to Jennifer via chat. She'll be monitoring that on behalf of everyone and interjecting across the presentation. We'll make sure we have time as well at the end to really go into more and more Q&A. So with that, let me dive in. A snapshot on Link Labs. We've been in the space as a company since 2014. Our core products we call AirFinder On-Site and AirFinder Everywhere, which is a seamless indoor-outdoor Internet of Things platform. AirFinder On-Site, think of as a product that's designed for large footprint facilities, manufacturing sites, hospitals, hotels, warehouses, schools, you name it. Anything that's relatively large needs a wide coverage area indoors. Outside of Wi-Fi is where AirFinder On-Site operates. AirFinder Everywhere extends that capability to over-the-road geographic coverage, not only in the US, but in many different countries as well. We've been doing this at scale for a while now. Just on the infrastructure side alone, we have over a couple 100,000 devices deployed and managed. We process about 1 billion events, and that's grown quite a bit recently per month. So we sort of know what it takes to kind of manage all the data that flows from asset tracking and monitoring. We're partnering with all the top tier players on the network side as well as the supply chain side. And we also have innovated a lot with almost 30 patents. I believe Mark is probably on the almost all of them, if not, but certainly the vast majority. So you're talking today with really a world's expert in how this technology works at a very fundamental level. So that's a little bit about us. We work with a lot of different industries and use cases. We're partnered with AT&T, and with them work with all the major hotels, Marriott, Hilton, Wyndham as examples here. We work in industrial companies, Georgia Pacific, Bombardier, et cetera, Senior Aerospace. We're working in hospitals, Hurley Medical Center, Johns Hopkins, construction companies like Sitemetrics. So a wide array of use cases in an enterprise setting with companies that had chosen to work with us. Now I need to advance the slides. There we go. On the IP side, again, just to give you a sense of where we're coming from, Link Labs has been on the forefront of Internet of Things tracking and monitoring technologies. We're the first company in the United States to have certified products that used a wireless device called LoRa, or technology called LoRa in the US way back in 2014. When the carriers, Verizon, AT&T, et cetera, adopted new Internet of Things technologies, which was called CAT-M or LTE-M1 back in 2016. We're the first company that actually partnered with them to bring those new technologies to market. We're the first company to actually determine location on a Bluetooth device itself back in 2017. We have integrated Bluetooth devices with network operator technologies. We've integrated in 2019 complementary technologies like ultrasound. We've since built technologies that allow you to track things indoors and out with fine-grained indoor location, as well as sort of classic outdoor location technologies that most people are familiar with. And then more recently, we have developed technologies that allows for very high accuracy, light infrastructure, power efficient indoor location capability, which is some of what Mark will get into as we talk about AirTags versus AirFinder. So with that, Mark, I'm going to turn it over to you to start to introduce sort of the heart of the plate conversation today around AirTags and AirFinder. So And I'm sure I won't be able to keep my mouth shut, so I'll jump in here and there.
All right, sounds good. Thanks. Yeah, so this is the Apple AirTag. Came out last year. I'm sure most people on the call are familiar with it. If you have an Apple product, maybe you even have like an Apple iPhone, maybe you even have one. I know I do. One way to think of it is it's basically Apple's version of Tile. It's for tracking devices for consumers, mostly personal objects, things like keychains and wallets and things like that. And the way it works is it's kind of I think you can think of it as a parasitic positioning system. So the AirTag, if you lose your keys or something like that in a park, is broadcasting its presence. And if someone with an iPhone happens to walk by, it will pick up those advertisements and ride on utilize that iPhone's network connection to get location out. It basically inherits the location of the iPhone. Like I said, this is similar. This is things that people have been doing for a while. It's similar to Tile. If you have any familiarity with those, it's kind of the same thing. The big strength with the AirTag is that it's riding on the Apple infrastructure, which iPhones are ubiquitous. So you stand a really good chance of someone with an iPhone walking by your lost device and helping you find it. Also benefits from being tight integration into the Apple infrastructure, so you can find my apps on your phone, or on your MacBook, so you can easily locate things. So that's kind of one way that it works, and really probably the primary way for most people that interact with AirTags is via that BLE proximity course positioning. The other way it works, or the other feature that it has, is what's called ultra wideband technology. So there's actually two radios in each of these. One is for Bluetooth and one is for ultra wideband. And we'll talk more in detail about ultra wideband and how it works later. But the idea is essentially it's proximity ranging. So it's kind of the last mile. I know that this thing is in this room, but I just can't find it. And so if you have a newer phone, I think iPhone 12s or later, that are equipped with UWB technology, you can enable that feature and really home in on it. I've tested and worked with these myself. I have a couple, like I said. It does work. We'll talk about kind of pros and cons and limits of the technology later, but for finding keys, it's great.
Yeah, Mark, can you touch on, I guess, form factor and sensing a little bit as well with AirTags? Sure. Are there many different form factors available?
Yeah, absolutely. There's not. So there's just the one, at the moment, there's one manufacturer of AirTags, which is Apple, and there's one form factor of AirTags, which is the one you see there. And it's slick. It's a very nice commercial, like everything Apple designs. It's a very nice design for commercial applications, for consumer applications. For commercial applications, it's a little problematic. It's kind of, I think we have a slide later with a picture of it. It's kind of, if you haven't handled one, they're kind of oval and roundy, no sharp edges, no flat surfaces. And so trying to mount this thing on something that you wanted to track would be a nightmare. It's practically impossible. So Apple, because they're shooting more for keychains and things like that, they sell, luggage maybe, they sell little dongles that you can clip these things into and attach to a key ring type thing. But yeah, there's not much in the way of commercial fixtures for these things.
Got it. And they don't do things like monitor temperature or things like that.
No, yeah, at the moment it's all purely location.
Got it. Why don't you, if you'd like, I'll jump to the next slide and we can talk a little bit about AirFinder.
Yeah, so what is AirFinder? So it's kind of a big term, really. It covers a lot of our products. At its core, it's an asset tracking system. It's really geared for commercial environments, business users, industrial environments. And there's a couple of different technologies under this umbrella. And so we have solutions that kind of fit in a lot of different places. And so one of our technologies is Bluetooth low energy based. and is proximity. So it's kind of similar to the AirTag course positioning. You know, these tags will essentially tell you I am closest to this beacon that I see. The other big technology we have is what we call XLE. This, and like I said, I'll go into a little more detail later, but this is a more precise location system, where BLE system is doing kind of course positioning via proximity. XLE is actually measuring distances to fixed points. You know, you place beacons at fixed points, and the tags will measure their location to them and then use that to trilaterate its own position in three-dimensional space. And then, you know, the other part of the AirFinder system is the backhaul network. And so, you know, the way I like to think of it is it's kind of like layers of data aggregation. And by doing this, you can, you know, shift the energy burden up. You know, so the tags themselves are very low energy because they don't have to talk very far. They don't have to connect to a Wi-Fi or cellular network or anything like that. They just have to get to the closest access point, and then, which is powered, and then that can flow the information back to the network, where then you can access it, you know, on your phone through an app, or you know, on your computer.
Yeah, Mark, I'm going to offer some clarification and then some commentary, which maybe, you know, also covered some additional slides. On the clarification side, you know, for folks that aren't familiar with the term proximity or beacon, you know, think of it as how loud am I talking? So if I was, you know, lost car keys with Apple's AirTags, the tag is literally beaconing, I'm here, I'm here, I'm here. And when someone's walking by with an iPhone, and they're not talking very loudly, you know, they have to be relatively close, you know, 10 meters plus or minus, for example. It'll be like, hey, I hear this person talking, you know, I'm car keys, and you know, I don't know if it even is activated, I'm car keys and I'm lost, but so Mark, maybe you can comment on that. But that's what it means by proximity. It's, you have to be relatively close. It's like your car keys talking to your car to unlock the doors. With AirFinder, one of the things that's unique is it's not a proximity to a phone. It's not a proximity of a tag to a phone. It's really, we have what we call fixed beacons that are in known locations. And again, a more B2B commercial settings. I have a beacon in every hospital room, so I know all the rooms, and I can tell you when a wheelchair, a bed, a infusion pump, a ventilator went into that room, because it hears that beacon the loudest as proximity. So that's what sort of the notion of a beacon. It's something that's just saying, you know, in the AirFinder case, this is room 123, 123, 123, and it's just constantly saying the room ID. And then when the tag walks in, the tag goes, oh, I hear this, it's very loud, I must be near room 123. That's kind of what's going on.
Yeah, and you know, and that's that highlights an important point that, you know, in the AirTag case and in other similar technologies like Tile, the positioning is opportunistic. If there's no one walking in that park, you don't know that your tag is there. Similarly, if you're trying to track assets in a hotel or a hospital, you know, or another commercial application, if no one's there at night, then you have no way of knowing what's there and tracking it. By contrast, AirFinder, you know, you install this fixed infrastructure, and now you have 24/7 asset tracking and basically kind of a guaranteed level of service that you are not guaranteed with something like AirTag.
Yeah. Actually, as you talk, it's bringing to mind for me there's actually multiple pieces of functionality being provided by the phone, the iPhone in this case. One is backhaul. You know, what is the path to the internet of that and that's through the phone, right? It's, as you said, parasitic to another user's phone is providing, you know, it could be providing, you know, that tag is near me back to the internet. So it requires, just for simple, you know, how does the information flow back? It requires the ubiquitous presence of phones. Works great in urban, suburban areas where everyone has an iPhone, doesn't work great, at night in the hospital or in a manufacturing facility where there's not a lot of staff walking around, that kind of stuff. You don't get, you lose your coverage, if you will. So where is backhaul? And then the other question is, where is location information coming from? In the AirTag Apple case, the location information is also coming from the phone. The phone is here. Put a dot on a map, whereas in the AirFinder case, location information is essentially a set of beacons that are installed in a facility that, again, provide consistent level of granularity. Can be determined essentially by the as you deploy more location beacons, you get more location granularity. So you're separating the notion of where is location from how do I get that information back to the internet. All those functions are actually through different capabilities that can be managed independently, whereas they're tightly coupled in the Apple AirTag case.
Yeah, it is an interesting point. It makes me think of another benefit of AirFinder, which is, it is, and we've had this situation happen before, where it is a positioning system. It's for locating assets. And so we've had customers that install this system to locate assets. And then after they install it, they decide, it'd be nice if I had a presence sensor over here. With AirFinder, you can do that because not only are you installing a position system, you're also installing an IoT network. And so you can very easily hang sensors, auxiliary sensors and things on the network, very little effort.
Got it.
You've
Yeah,
been
go ahead,
talking about how AirTag works outdoors, anywhere you've got self-service through the phones. AirFinder having that indoor facility map. What if I want to take my AirFinder tag outdoors? What happens then, and what technologies are you using, or is it only indoors location?
Mark, you want to take that one, or want me to take that one?
Sure, I can start it, and you can jump in. Yeah, so we have another product kind of in the AirFinder umbrella called SuperTag, which can kind of act as a mobile access point and location beacon. It can also, by itself, if you know that something you're tracking is going to be indoors and out, and you want to track it itself, you can place a SuperTag on it, and that device has a number of radios. In addition to Bluetooth, it has Wi-Fi, it has cellular, it has GPS, and it will automatically kind of switch over to different technologies, whatever it needs to locate itself. And it's all very configurable. And then again, you can use it as an aggregator for tags. So if a tag moves out of a indoor network and moves in range of one of these super tags, it can aggregate and forward that data as well.
Yeah, it's a great question. I like to think about this as what radio technology is in the tag, and different radio technologies cost different amounts. So there are some pros for AirTags here. If you're trying to, again, assume that you drop your car keys in an urban suburban environment, you want a Bluetooth tag because it's low cost, basically, and it can last quite a while on your keychain. And because you're parasitically picking up other people's iPhones, there's real value in the fact that iPhones are relatively ubiquitous. You could find them. AirFinder is not really designed for that use case. AirFinder, when it is a low-cost Bluetooth tag, really requires an AirFinder network. So you're sort of more limited to where you have an AirFinder indoor network established. Again, think large footprint facilities, manufacturing sites, hotels, hospitals, that kind of stuff, where you would not want to rely on the ubiquity of third-party iPhones for finding, again, devices in a manufacturing facility, a hospital, particularly a warehouse. Very few people, where is something in a warehouse? It would never get found. With a Apple AirTag, whereas with an AirFinder network established, at very low cost in a warehouse, you could definitely find something. The super tag, as Mark was talking about, is a more expensive tag. It has a basically dual functionality. It has a Bluetooth chipset in it, which allows it to act just like a Bluetooth tag when it's inside an AirFinder network. So you can do everything I just described indoors, and it's cellular enabled, so that when it transitions out of a facility to the world at large, then it fires up its cellular radio, and now it's acting, if you will, like a phone itself. It doesn't require parasitic, utilization of other people's phones. It can be anywhere, and it's using, leveraging, direct connection to a cellular network, and actually it can be configured to operate on multiple cellular networks, so that it can, depending on which network is actually, functioning, select that network. So that's a little bit of the difference there. Should I move on?
Mark touched on it too, but that GPS and cellular functionality also allows the Bluetooth tags to travel with it, like a leash or a hub capability, providing that lower cost as well. So,
yep. Yeah.
No other questions at this
point. Yes, we touched on this a little, but this, just kind of shows you what the components of the AirFinder indoor system are. So obviously, you have asset tags. We've got a number of different form factors. The technology in each is the same. They're all based on a Bluetooth radio. But the form factors, we have a card type form factor that's sealed. So it's got a higher IP rating. We have some with replaceable batteries. The one on the far right there is, you can't really see the scale, but on there, but this is one of those. So it's very small and thin. So a number of different tags. Then there's what we call location beacons and access points. As Bob mentioned, location beacons are kind of the fixed infrastructure at known points that the tags use to locate themselves. And I think we touched on earlier, that's kind of a big distinction of the AirFinder system. Our approach has always been for tags to locate themselves. And there's a couple of different reasons for it. Cost is one. A common approach to BLE positioning is to use tags that are broadcasting. And so they're just advertising their presence. And then you might have collectors stationed around an area that are listening for these tags and then forwarding these observations. I saw a tag XYZ at this signal strength in this time. And that was actually an approach we took early on. And the problem we found is that to position, to locate things accurately with a system like that is actually very expensive. The amount of data that you have to flow back to the back end over often a cellular link is tremendous. And so, after we received our first $3,000 cell phone bill for one of our gateways, we decided maybe we need to rethink this approach. So, to do that, we flipped the link around and made the beacons broadcast. This also has the benefit of beacons are cheap because they're just BLE radios effectively. They don't actually have to connect to the back end. So the tags listen for those beacons, they locate themselves, and then we have access points that do have a backhaul connection that the tags connect to, and those access points forward their data onto a gateway. As I mentioned, that gateway is cellular, so we don't touch customer Wi-Fi networks. As anyone that's tried to get on a business Wi-Fi network, it's not easy. IT is very protective, as they should be, of those networks. So our system rides completely separate from a customer's network, and then forwards that information out to the fourth component of the system, which is our cloud-based IoT platform. So you have a UI, you also have a suite of APIs that you can use to access your data. And if you have your own UI, for example, you can access your data from our platform and display yourself.
Yeah, it's probably worth, let me jump in here and talk about the cloud side a little bit, and we'll probably have a little bit more on this later, but that's a big distinction as well, is, what are you trying to do with data and information? We've talked a little bit about tags and location and network, but we haven't talked about the software. If you want to have an industrial footprint floor plan as an enterprise, again, multi-story facility, you've got hundreds of assets. You want to know they're in certain areas. You want to have a map view. You want to have a list view. Now you want to understand battery life and remaining battery by hundreds of assets, and start to do analytics or basic reporting on show me all the batteries and where all the devices that may be running low on battery, filter for that. Or I'm looking for a certain type of equipment in an industrial setting, show me those on a map or give me a list view. So when you start to imagine leveraging many assets with lots of data and all the things you need to do from a visualization, standard reports, that kind of thing, this is where this cloud platform on the AirFinder side, it was completely different than what we would have as a consumer application and Find My, kind of show me a dot on a map capability. Let me push us along. We touched on this before, form factors. There's another view. Any additional commentary here, Mark?
No, I think we covered that.
We've touched on AirFinder tags here. I would also note that the other way to think about AirFinder is it's very extensible at the edge. Really, the platform can utilize any relatively recent device that incorporates. Today, we primarily utilize Nordic Bluetooth chipsets, which are in 2/3 of anything with Bluetooth in it. But there are dozens, if not hundreds, of potential devices to pull data from and ingest them into the AirFinder platform. And that's a really light lift to kind of add additional tags with different types of sensors. Mark mentioned proximity earlier, humidity, temperature, shock, vibration, all these different things that you might want to know in a commercial environment. Door open, closed, refrigeration, etc. All that can be done with the AirFinder platform because of the kind of breadth of tag form factors. And there's a question that's often come up with, like, well, why Bluetooth enabled devices? And I think of it as affordability. You want all these different form factors so you can handle many different use cases in a commercial environment. But you also want all these tags to be low cost. So you have to simultaneously solve for many, many different form factors, but all of them inexpensive. Low cost comes from high volume. The only ecosystem of tags and sensors in high volumes that really should be applied or can be cost effectively applied into a large commercial setting is the ecosystem of Bluetooth enabled devices. And that's why sort of pretty much any Bluetooth enabled device can work in the AirFinder platform.
Mm-hmm. Yeah,
Question around whether the system would work in any hazardous environments.
That's a great question. So there are intrinsically safe tags that have Bluetooth technology embedded in them from third parties. Again, what the AirFinder platform does is co-opt third-party hardware, if you will, that has Bluetooth chipsets in it, that allows us then to utilize a lot of, frankly, what Mark's invention and done on the firmware that sits on those devices to make them performant in this kind of platform. So intrinsically safe devices, to the extent they're out there and exist, can be leveraged into this platform. To me, the open question I have in the back of my mind is finding the ones on the infrastructure side that would allow that to happen. But again, on the infrastructure side, anything's possible. And there may be some certifications, that kind of stuff, but we would probably leverage an existing piece of infrastructure as a starting point.
Mm-hmm.
Mark, any other comments, or should I?
No, I was gonna emphasize that yeah, the tag hardware is all off the shelf. Neither are Bluetooth Low Energy based system, or our XLE ranging system requires custom hardware. It's all kind of stock BLE.
I'll turn this over to you to kind of summarize.
Sure. Yeah, we'll touch on a couple of these. These are just kind of head-to-head comparisons here. So, cost, as Bob mentioned, it's a big one, and the AirFinder system is based on, and the tags are based on off-the-shelf Bluetooth technology, which is, about as cheap as it gets. There's a host of manufacturers, and price is the major way they compete in these radios. So, the consumer benefits from that, and you can get Bluetooth tags at a much lower cost. The AirTag is a very slick commercial commercial product. So they're more expensive. The other thing, and this really applies to both, the AirTag and other ultra wideband based technologies, is, and I'll explain kind of why on subsequent slides. But with ultra wideband tags, what you'll find is they always have two radios. They always have an ultra wideband radio, and they always have a Bluetooth radio. And like I said, I'll get into the reasons for that, but you can kind of think of it as, one way to think of it is ultra wideband is always going to be a cost adder, because it's an extra radio. You're always generally going to need two radios. So big price difference. In terms of the radio technologies, they're both Bluetooth or Bluetooth-like, and so communication distances are pretty similar. The difference with AirFinder, as we've said, is that you're laying out, indoors, you have fixed infrastructure, and so you kind of have that guaranteed coverage. Whereas with the AirTag, your communication range, your network is based on someone being within communication range. And then, again, with our AirFinder system, we have technologies that leverage, cellular networks as well. So with those technologies, you can kind of go anywhere now. In terms of accuracy, so, I'll touch on this a little later as well, but in our proximity-based system, we like to say that the accuracy is plus or minus one location beacon. And so the more dense your location beacon placement is, the more accuracy you have. With our XLE three-dimensional system, in good conditions, we can achieve sub-meter accuracy. In general, it's more on the order of 1 to 3 meters. Which, as Bob likes to say, is arm's length. So for most positioning, that's kind of all you need. The AirTag, again, it inherits its location from whatever iPhone it's talking through, and so your positioning accuracy is based on that. If that phone is outdoors in GPS mode, you might be, and you happen to walk very close to this tag, then your accuracy could be really good. If it's indoors and it's doing Wi-Fi fingerprinting, then you might be off by a couple floors or whatever. So in its ultra wideband positioning mode, you can get very accurate ranges. The problem is in my testing, at least that I've done with these, the distance is, you got to be relatively close for that mode to actually work properly.
Yeah, I think of the ultra wideband mode in the AirTag as a homing device.
It's
when you were a kid playing hot and cold, hotter, warmer, and you can kind of finally, you can work your way to reasonable, to finding something that lasts 3 meters where the Bluetooth accuracy isn't sort of working for you.
Right. And one thing to note too, like in my testing with it, is there's a phenomenon called multipath, which is when a signal that's transmitted from a device, it has the direct path to the receiver, but it also could have multipath. So it propagates in all directions, and so maybe it bounces off of a refrigerator or something, and then that signal comes at an angle. And for ranging systems, it can be a problem, because if for some reason you don't get that direct path and instead you only see that bounce, then as far as the tag is concerned, it's going to measure that bounce distance, which is generally longer. And so when you're doing the hot cold thing with an AirTag, if the tag is by something metal or your direct path is obstructed, you're only looking at one data point, basically, the one range that you're measuring, and so you could be way off. As I'll discuss later with our XLE system, it similarly is measuring ranges. The difference is when it's calculating its position, it's using a multitude of ranges, and so those errors tend to either cancel out, or the tag is smart enough to detect them and discard those measurements. So you generally get better accuracy because you got multiple views.
Cool. Let me, I'll cover the last ones here.
Sure.
Battery size, I'd note on AirFinder, as you look back and think back at the tags we just showed, there's different onboard battery sizes in different tags. So you get a wide range of onboard power, which means you can get a wide range of operational life. And then basically you can select a tag with the battery capacity, and depending on how often you're utilizing it, to get to the operational life you need for your use case. I'd also note that both chargeable and rechargeable, sealed, some are disposable versus battery replaceable. So kind of every permutation possible is available because you have this really broad ecosystem of tags available to you, whereas you're kind of limited to an AirTag, onboard power, how it operates. You're kind of stuck there in that particular case. So just completely different levels of flexibility and tailoring to different use cases. I think you touched on the location technologies a little bit, and we've talked about again sensors and the fact that there's just a wide variety of sensors, and pretty much any sensor you can imagine today tends to be coupled to Bluetooth technology. So, temperature, acceleration, humidity, shock, pressure are all sort of classic things you need in a commercial environment. But we also see things like indoor air quality, particularly in COVID, sort of post-COVID world, really critical for certain applications. There's really no condition monitoring whatsoever. And then beyond condition monitoring, you can think about it as, conditions are, you create essentially a state machine associated with sensors. Tell me when the temperature exceeds a certain bounds. Tell me when shock, exceeded a certain threshold. Tell me when the air quality is not proper. How do you run that into a set of dashboards, thresholds, alerts, send me an email or a text message when such and such happens. So that's, again, part of the difference here.
Around location technologies, we had a question around whether the Bluetooth in a laptop could be enabled to find itself on the AirFinder network. Bob, you want to take that?
Yeah, I think I kind of think of this as anything is possible, provided that we've got the ability to have a little bit of an application that would operate that. So that is not something that we have had a demand to actually build, but I don't see why that wouldn't be possible. But Mark, maybe I'll let you jump in as well.
No, I was just thinking, I think for the Bluetooth-based AirFinder system, it could be possible. But yeah, we don't have anything like that right now.
Yeah, but it's more a question of demand. If somebody said, hey, I want to know where all the computers or laptops are in my enterprise setting, there's probably a piece of software we could put on to a laptop that would essentially fire up the Bluetooth radio. The gating question really would be, when that laptop is closed and powered down, is it even possible for the Bluetooth radio to be turned on as a vendor? If not, no one can do it. If it's possible for it to be turned on and operate, kind of a beaconing mode, then certainly can work in the AirFinder network. But I'd also note, we have had inquiries with super thin, almost sticker-like Bluetooth tags that are aftermarket, mounted onto laptops and other electronic devices.
Thanks.
Additional comparison information, we've talked about form factors again, tag options, API. Our understanding, Mark, you've looked into this a little bit, there's very limited ability on the API side. Again, think of an enterprise commercial scale solution is what AirFinder is, with full suite of APIs to take that data and information and run it and couple it into enterprise grade software systems. That's not what's available inside AirTags. That's much more of a B2C product. Security, privacy, AirFinder runs on its own network, location data to the cloud. So it's it's basically a self-contained solution, independent of customers' Wi-Fi, customers' IT systems, also independent of third-party devices like the parasitic use of phones in the AirTag example. So again, from a security perspective, you control everything. And it sits outside of other systems, so that the IT functions in enterprise settings tend to love the AirFinder solution because it doesn't touch anything else. Scalability, unlimited number of users, very limited again on the AirTag side, 16 AirTags or so. So again, sort of summing it up, AirFinder is really a business-to-business enterprise asset tracking and monitoring system, whereas we think of AirTags as a business-to-consumer capability. May work for very limited number of use cases in, call it, small businesses. I've got, a small business that has a set of keys that somebody may walk out the door with and drop somewhere, like we discussed earlier. AirTags may be fine for that. You're only tracking a handful of things. You're really almost using it like a consumer. It just happens to be in a business context. But in general, it's a business to consumer business model, and it's a consumer application. AirFinder is a true enterprise application, but it's really meant as a business to business sale and business model. We talked a little bit about the system. Any further commentary, Mark, Jennifer?
No.
Cognizant of time, I think we're coming up, but Mark, we've got about 13 minutes left according to me, so we've got a couple of slides that are deeper technology, I think, which I think some people would really enjoy.
Sure, yeah, I can go through these. So we wanted to just kind of focus on two of the technologies we talked about today and go under the hood a little bit. So we'll talk about ultra wideband in detail, and then we'll kind of contrast that with the our XLE system in some detail. So ultra wideband, if you're not familiar, and as the name would imply, it is based on the transmission of these really short duration, we're talking nanosecond, but wide bandwidth blips. Now, if you're trying to locate something, through time of flight ranging, which is where you have two radios, and they effectively, one transmits a signal to the other, and then that one transmits a signal back, and you measure the amount of time it took that signal to go all the way around. And because the speed of light, you can back out the distance between those two objects. So that's time of flight ranging. So when you're trying to do that, and you need really good time accuracy, because the speed of light is fast, it's a nanosecond per foot. And so, you need, if you want to measure that directly, you need picosecond resolution. And so the way you can get that is with a wide bandwidth signal. It allows you to resolve it in time very well. So that's what ultra wideband does. It transmits a wide bandwidth signal. Now, what I always like to point out to people and get out front is that if you're looking, if all you cared about, your only metric was the resolution of a particular system, ultra wideband's, kind of the king. It's the widest bandwidth system, very high resolution, and very high accuracy. We're talking on the order of centimeters. The problem is its cost. There's only a handful, I think 2 or 3 IC vendors that are making ultra wideband systems. Apple is one, and their ICs are not commercially available. The other is actually, I think it's Qorvo now. It was a company called Decawave, but Qorvo bought them. Those are the ones. That's the one I'm most familiar with, and that's the one that almost everybody uses. I believe Samsung might make an ultra wideband IC as well, but I've not seen that one in use much. So you effectively kind of have one commercial vendor for these chips, and because they're transmitting a really wide bandwidth signal, they're complicated radios, complicated ICs, and so they're expensive. They really can drive up the cost of a system, and to generate and transmit this signal consumes a fair amount of current. The numbers I give for comparison. So Bluetooth radio, when it transmits, draws on the order of maybe 6-7 milliamps. A ultra wideband chip draws around 140 milliamps. It's a tremendous difference in energy. Now it draws that current for a very short period of time. Nevertheless, if you use that a lot, you're going to consume a fair amount of energy. And so that's why I alluded to this earlier. That's why while they're technically usable, you can use an ultra wideband radio to communicate. No one does because of the energy consumption of that radio. So that's why they pair it with a Bluetooth IC, which handles the communications. And so kind of therefore that's why I say ultra wideband is always a cost adder.
Yep.
And again, since there's only one bit, it's not commoditized. So, sorry, go ahead, Bob.
Oh no, I didn't mean to interrupt. It's really brings to light, sort of why do AirTags work the way AirTags do, and how do you think about this stuff in an enterprise setting? So Apple did embed ultra wideband in the AirTag, but it's only utilized very rarely when you're operating at this sort of last few meters homing mode. But otherwise, that radio would draw too much power as its primary location solution. And so, you couldn't get to that size and form factor using ultra wideband alone with any kind of reasonable operational life. So, you're sort of forced to use both, as you noted here, which drives up the cost, and AirTags are much more expensive. And then you're really only using ultra wideband, extremely rarely in the AirTag case. If you want that kind of high accuracy all the time in a commercial enterprise setting, and you look at some of the vendors you have here, like Zebra or Suio, those tags are bigger batteries and they're expensive. Think $65, $70, $80, and super high volumes, $30 to $40. And the problem is like there aren't super high volumes in an enclosed space of assets that you'd spend that kind of money on tags on. You're just like, well, it's not really worth getting that level of accuracy. So I think of ultra wideband in an enterprise setting as very limited number of use cases. You want to do collision avoidance with forklifts driving around a warehouse where you want that precision to be really high, or you're flying a drone indoors in a warehouse or commercial setting, and you can't have it crash into something. But outside of kind of that kind of super high demanding location accuracy, where you have a limited number of assets, where you're like, if I spend $50, $60 on a tag, but I'm only tagging 10 or 15 forklifts or a couple of indoor drones, like that's no big deal. That's where that plays. But if you said I want to tag every item in the warehouse and I've got 10,000 of them, it's a non-starter to spend 50 bucks a tag.
Yep.
I'll jump to the next one here in the interest of time.
Sure. Yeah, so I'm going to go over our on-site XLE system. So, and really this is, I'm going to kind of directly compare it with ultra wideband in some ways, because similarly, it's a time of flight system. The tag is measuring a range to a fixed point. The big difference is that we take a drastically different approach to how we measure that time. So like I said, ultra wideband is transmitting this really wideband signal and measuring that time directly. What we do is we use a technique called multi-carrier phase ranging, where we, instead of measuring time directly, we actually measure the round trip phase of the signal. Why do we do this? Well, one is because low-cost radios like Bluetooth chips are really good at measuring phase. They're not so great, at measuring time with extreme precision. They can't get down to picoseconds, but they can measure phase very, very accurately. And that's because that's how they communicate. When they send data, it's encoded in the phase of the signal. So they're great at measuring phase. And it turns out that if you do it properly, if you follow some rules, you can synthesize bandwidth with these radios. So instead of transmitting a wide bandwidth signal in one shot, we actually transmit a bunch of narrow tones over a bandwidth, and then we stitch them together to synthesize a wideband signal. And so that's how we are able to get 80 megahertz of bandwidth from an IC that can't operate over 80 megahertz in one shot. The other side effect of this technique is that the processing to do this, to calculate these range measurements, is extremely efficient. We do it all on tag. No custom hardware or ASICs needed to do these calculations. So, the Bluetooth chips are completely capable of doing it. And as I mentioned, it's compatible with stock off-the-shelf BLE 5.1 tags. So in terms of accuracy, sure.
Yeah, go ahead. Touch on the accuracy. I'm just cognizant of we've got about 5 minutes left.
Sure. Okay.
So touch on the accuracy and some of the other advantages, because we haven't actually talked about some of the stuff in the lower end of the slide here.
Sure. Yep. Okay. So yeah, the accuracy, I think I touched on it before. Good conditions, clear line of sight, not a lot of interference or multipath. Sub-meter is possible. We have knobs to twist as well. Tags can do more averaging and things like that to get those accuracy numbers down at the cost of energy. Typical environments, I like to say it's 1 to 3 meters. And I've got some kind of example installations and tests we've done. The one on the lower right, I'll call your attention to. That was an actual picture from where we tested. That's a transmission shop. It's a horrible environment. Metal everywhere, cars on lifts, they're blocking beacons. And as expected, our accuracy went down. But again, by increasing the averaging done on the tag, we were able to get that down into the 3 meter range, which for that environment is really good. So I'll just touch too on as we mentioned, it's extremely low power. It was designed with power consumption, minimizing power consumption in mind. All the communication, it's an IoT network. So communication is bidirectional, it's fully acknowledged. We can do firmware updates over the network. So once you deploy those tags, you don't have to touch them again, except for, to change batteries every couple of years or something. And again, similar to our BLE-based AirFinder network, you can also use it to flow generic data, sensor data, things like that.
That's great. Yep, thank you.
Mm-hmm.
I think, we've touched on this. I'll just sort of wrap us up here, if you will, and then Jennifer, if there's any questions coming in on, again, think of large footprint facilities, commercial settings, warehouses, manufacturing sites, construction sites, distribution centers, logistics, operations for over the road. That's what the AirFinder system is really designed for. Infinite scalability, manageable from both an infrastructure tag operational perspective from the cloud, ability to do any kind of customer analytics reporting capabilities, role-based ability to utilize the platform. So on the software side, right, enterprise software. AirTags are sort of a consumer solution. You could play around in a commercial setting, but you could never really have an enterprise solution operating at scale with complete reliability that you get with an AirFinder system. So with that, we've got a couple minutes left for maybe 1 or 2 questions, Jennifer.
We've had some questions on cost. Do you want to just touch on ROI and how we work with our customers on that?
Yeah, I'll just note that the way we think about this market is from an affordability perspective. I like to think of, the things that people want to track and monitor already exist in the vast majority of use cases. Hey, if I only knew where this was or how it was doing, that would be a great thing. And when they go out on the market and they look for a solution that meets those needs, they say, that's too expensive, I'll just buy another one. So the AirFinder platform, relative to any other enterprise tracking and monitoring solution on the market, is fundamentally much more affordable. And we've been told this by many customers over and over again. The specifics of cost get very use case dependent, because the amount of infrastructure that's required, the type of tag you use. You saw the range of just tag costs, $8, $15 for the intrinsically safe question. Those tags are probably much more expensive than that because of the industrial hardening and the safety features associated with them. Cost varies a lot, but what I can say is relative to other solutions that someone might deploy, it tends to be factors of 2 to 5 or 6 less with the AirFinder solution than any sort of competing technologies people would consider.
Well, that brings us to the top of the hour. Thanks, Bob and Mark, and thank you for listening. If you would like a demo, or if you have any questions about your specific use case and how the technology might apply to that, we would love to talk to you. Feel free to put that into the questions box, or go to our website and you can click on the request a demo and we'll reach out to you. Thanks for attending, and we'll be in touch.
Thank you, everyone. Really appreciate your time today.